All right, so this is Astro, the hopeful future of DAG writing. So in this webinar, we're going to be going over the why of kind of creating a new DAG writing paradigm. What did we actually end up creating and what is going to come next? So to start out with, why did we make this? Why did we make a new DAG writing paradigm? Well, for those of you who are around in around 2020, 2021, we had a pretty massive release with Airflow 2.0, and we really made a lot of really necessary and really foundational fixes, things like the HA scheduler, the task flow API, separating out all of the operators into independent providers, and just all sorts of deep down and infrastructure level fixes that really stabilized and allowed the project to scale. And a really good piece of feedback we got from a lot of people was, this is all really great for the Airflow admin. This is all really great for the kind of people who are running the Airflows, but as a data engineer, what do I get out of this? What are the features I'm getting that are going to make my life easier? And so we at Astronomer kind of went back to the drawing board and said, that's a fair piece of feedback. What can we give to data engineers and data scientists and data analysts to make the people who are writing the DAGs have an easier time? And what can we do to build an experience that is more fitted to what they would do in a non-DAG setting? And so when you look at DAG authoring today, it involves a decent understanding of Python and the target language system, but it also involves a decent amount of understanding of Airflow and how Airflow works. So you need to know what a task ID is. You need to know what how these connections work. You need to pass in a lot of metadata on a per task basis. And it's also a little repetitive because you can set dependencies between tasks, but that's all you're doing. You're just saying, do this after this. There's no kind of understanding between the two in the sense that you have to redefine all the connections. You have to redefine all the metadata, and you could pass some stuff between XCOM, but it's pretty simple the amount of data you're allowed to send. So with Airflow 2.0, we wanted to start the process of simplifying the DAG writing process. And so the first kind of step towards that was the task flow API. And this allowed anyone to take a Python function, wrap it with the task decorator, and now all you have to do is call that function, and you can set this kind of functional dependency to create Airflow tasks. Which was really kind of a cool first experiment, kind of a cool setting the foundation, but it wasn't super powerful yet because all you're kind of doing is you're adding the syntactic sugar, but you're still not seeing a lot of the major benefits that could come from a more intelligent XCOM system. And so when we were looking into what we want a next generation of DAG writing to look like, we wanted it to be really native Pythonic feeling. So, it should feel as close as possible to just writing regular Python. We wanted people with no prior knowledge of Airflow to have just a really easy learning curve, and also just this ability to read a DAG without knowing Airflow and still understanding the vast majority of what's going on. And we wanted the tasks to be able to interact with each other in rich and meaningful ways. And so with that, that's where we're really excited to introduce you to Astro. Now, when we talked to some of our customers and some of our people in the field, we found that a fair number of users were saying that a lot of our use cases involve around Snowflake or Redshift or some form of a SQL library or SQL system, and Python, and the ability to run distributed Python tasks. Those are the two major use cases. If you could handle those two things, that would make my life so much easier. And so we wanted to start from the bottom and say, cool, we've separated out all these providers. So now we can kind of create a more opinionated DAG writing experience from the ground up, making assumptions and working directly with data engineers as we do. And so, when it comes to a better Airflow SQL story, we want to be able to handle the common cases of ELT. So load the data, be able to transform tables, do appends and merges to existing tables, But we also wanted to do it in a way that makes it as easy as possible to do best practices. So, poorly formatted SQL can lead to SQL injections, which can cause security issues. So we made it as easy as possible to template your SQL in a way that's safe. And hot swapping is a pretty new SQL paradigm that minimizes the amount of downtime, because now instead of merging into a production table, you can just merge into a temp table and swap them at the last second. And finally, we wanted this to be still Pythonic, and we wanted to create a system where now SQL tables can feel like Python objects that can be passed between Python functions using as if they're Python objects, essentially. And so just to kind of feel more natural, feel more simple, and just really write out an ELT pipeline without having to worry about a lot of the internals and what's happening underneath. So this is where the AQL.transform function comes in. So you only need to define the context at data load time. And so you can automatically go from SQL to Python and Python to SQL using this AQL, which is seen here. So basically, you would import from Astro import SQL as AQL, and you basically just write a Python function and say, cool, in this Python function, I am aggregating orders. So give me an orders table, and I'll select the customer ID and the count, and I'll be able to use both Astro's templating and Jinja templating. So if you look here, you'll see that by defining the orders table as type table in the function definition, we now know that we can treat this as a table in the SQL statement, do all forms of security checks and all forms of templating checks before it actually goes to your SQL system, so it's handled correctly. And you can still use Jinja to make sure that all of the things that Airflow would provide, things like execution date, task ID, DAG ID, those are still available to you as you're writing your DAG. We also wanted to simplify the process of loading data into SQL and pulling data out of SQL. So we're starting out with CSVs and JSON. So you can load a CSV or JSON file from, say, like S3, GCS, the Azure storage, and say, here's the path to my S3 file or S3 bucket. Here's the connection ID I would use to connect to it. And then you'll see it outputs to a type of table. And so where table comes in is by defining the name and the connection ID, all the metadata you put into the table object is actually passed on between tasks. So you don't need to keep redefining that. You only need to define it one time, and all subsequent tasks will be able to just say, cool, I can see that I'm reading a table with table name foo using the Postgres connection. I'm going to make an assumption that that is where you want this information to live. We also handled certain SQL functionalities. So for example, one thing we wanted was the ability to switch between SQL flavors without needing to really change around your code too much. So merges are something that are drastically different between different flavors of SQL, be it like Postgres, Snowflake, MySQL, all of them do merges differently. So we offer a merge and append function to ensure that if you use our function and you switch from Postgres to Snowflake, it will still work on both of those systems without changing any of the actual code. We also wanted to offer data frame integrations. And this is one place where I think this gets really, really cool is, we offer this data frame decorator. And what's really cool about the data frame decorator is if you pass a SQL table into this function at DAG writing time, we will automatically convert that table into a data frame, run your Python function, and then you can return that data frame as a data frame, or you can return it back to that SQL system as a SQL table. And you don't need to decide that until the DAG is actually running. And so this is, I think a lot of this will come together as I show you this demo to just kind of show you what a DAG looked like before and after the Astro library. So let me quickly change up screens to show you what a DAG looked like before. So this was a DAG that was created by one of our field engineers, Kenton. And she's actually been one of the people kind of dog fooding this system. And so she wanted to create a DAG that takes data from S3, puts it into Snowflake, makes one or two transformations, does a data frame action, and then puts it back into Snowflake at the end. And so you'll see she's using the TaskFlow API, but it's not quite like the easiest thing to do. She has to define all of this metadata up here. She has to pull in some of the metadata in the TaskFlow functions. She has to do SQL queries in the TaskFlow, like pull out the data frame, and she has to do all this stuff. And then she also needs to know that she needs to know that there's an S3 to Snowflake operator, or that there's an S3 to Postgres operator. And like to swap between any other SQL flavor, she needs to go and change the actual code in her DAG. And she needs to, like, for all we know, maybe there isn't a GCS to Snowflake operator. So now someone needs to make that. And so you don't have that interoperability. And then even though she's using the TaskFlow API, she still has to set explicitly these dependencies to actually write out the DAG in a way that would work in the order that she wants. And so by comparison, let's take a look at how this would look with the Astro API. So, you define your Snowflake connection and your file path. You have this transform function, which actually handles the SQL. You have a data frame function that makes the assumption of this being a data frame. And now if we actually look at the DAG written itself, all you need to know is, cool, I am loading this file from S3, put it into this table, and you'll see here at the extract data level, it just takes in the subscription data object. And the subscription data object already contains all of this metadata. Like when you're say doing the append doesn't need to have a connection. It doesn't need to have like a table name, database, or anything like that. Like it doesn't even need this connection ID. All you need to give it is the main table, the append table, and the columns, and it's able to say, cool, I know what tables I've received. I know where those tables live. Therefore, I can do these transformations. And so with purely Pythonic functional dependencies, you're able to make a pretty complex ETL DAG where you're able to perform a SQL transformation and a data frame transformation, output that data frame transformation back into a table, and then append that new table into the main table. I'm going to take a moment to see if there's any questions, and then we can continue forward.
Daniel, I have one from you from the chat.
Sure.
Is there anything here for, as of today, for cross DAG dependencies?
So I would say that, can you explain a bit further what you mean there?
Yeah, I actually think I can even answer this one from what I've seen here. So as of right now, the context is for a specific DAG or a set of tasks in a DAG. Mm-hmm. We're not yet touching cross DAG dependencies, maybe in the future, but that doesn't seem to be where we're functionally at today. Like your context is going to be specific to what you're doing in a DAG.
Yeah. Cool. So yeah, I can continue on just a little bit further. Sorry. And so finally, just to talk a little bit about what's next. Well, what's next is that we want to hear from you. This project is on GitHub. It's available for alpha. Right now, we have support for Postgres and for Snowflake. We are very shortly adding support for Redshift and BigQuery, but we want to be able to hear, hey, like, what if it had this functionality? What if it supported this database? What if it supported this input? Like maybe you want a Snowflake connector, maybe you want an maybe there's a certain connector that would make this work really well within your system. So we want to kind of open this up as a conversation, and we want people to take a look, submit issues, and we really would just love to hear from you what you would want in this library. Great. And thank you all so much. And yeah, definitely open to question Q&A.
Awesome. Well, that was so awesome, Daniel. I'm really excited for us to kind of be thinking about our users in this capacity. I've been answering some questions in the chat, so I'm just going to start feeding them towards you, feeding them to you. Yeah. As of today, do we support upserting? And if not, is that in the cards at all?
So actually, yes, we do support upserting. So we have the merge function, and in the merge function, you have the option to pick a strategy. So you can pick the strategy of ignore or the strategy of update. And so if you do merge on update, that would be an upsert.
Perfect. Next question is for as far as getting started goes, will the repo have the steps I need to get started? Yes, the repo should have all the steps you need to get started, and anything that you find confusing or prevents you from getting started, that is, to me, a documentation bug. So I would love to hear if you run into any issues. We will be monitoring this closely to make sure that we answer your questions as quickly as possible. Community health is very important to us. Awesome. Next question would be, so you said something about the taskflow API at the start. Is this kind of leveraging some of the XCOM backend magic for functionality? Yeah, so this is built on top of the taskflow API, but we're basically kind of building on top of taskflow API, but taking a lot of advantage of what a richer XCOM system would look like. So, the XCOM system handles small amounts of metadata. How much can you do with that? And then, of course, looking into adding a better way of handling XCOM backends for larger data sets. Awesome. Someone asked, is Astro open source? Yes, it is. I can post the GitHub. We can post the GitHub link somewhere. Yep. Raj, where would be best to post that? I just posted in the chat, and it'll be in the follow-up anyways, so you will definitely get your hands on it. And to be clear, it's open source with the Apache 2 license. So, abuse it, contribute back. We are very open to any PRs or feature requests. Awesome. Let's see here. More sample code. Yep, Paul, there'll be some example code set up in the follow-up. So I will mark that as done. This one. Daniel, I have a question for you. Sure. I think this is based off some folks have asked, right? Like, who does this help? Who's this kind of geared for? Yeah, so I'd say that this is to help anyone who's working either with Python or with SQL, or frankly with both, which I think pretty large portion of our industry. We really want to help we see a lot of companies where there's a small number of kind of Airflow experts handling a large number of people who don't want to think about it. So our hope is that this library will help the people who don't want to think about it get more done before they have to ask that small number of experts, as well as we think this will just help people kind of get onboarded into the experience. And we hope this kind of becomes the gold standard of DAG writing. Awesome, awesome. Or at least a way for people to do things if it makes sense for them. I think that for a lot of users in the warehouse, this will make a lot of sense. I think if you're maybe not using Snowflake or in a cloud data warehouse and you're using Airflow for, coordinating some on-prem systems, I think the declarative approach is still really powerful. It just kind of opens up some more functionality. Yes, that's a good point. Is that this is more specifically for people who are handling and moving data than it is for just kind of making sure a series of systems are up in a certain order. Awesome. Question about the DF decorator. Is it transforming the output to a Pandas data frame or PySpark as of today? So as of today, it's transforming into a Pandas data frame, but that is something that we're looking into distributed data frame
we're looking into distributed data frames as well. Some of you might know that sometime last year, we released some work with AnyScale, creating kind of array decorator, and we were able to get Dask functionality there. So things like Dask and PySpark are certainly things that we're looking into as well.
Awesome. And then as far as usability goes, Daniel, I think this is another great point. Once I'm looking at my DAG in the Airflow UI, is it any different? You know, do I still get the DAG that I know and love in the UI in terms of getting logs and retries and all that good stuff?
Of course, absolutely.
Yeah.
You get the DAGs that you love, and eventually we were hoping to even add a little bit more so that as you look into these tasks, since we know the metadata, since we control the data in between the tasks, there's rich information that we can surface to the Airflow user in the Airflow UI.
Yeah, awesome.
Steve, to your question about the Pandas data frame, you know, that's a great question. That is part of why we eventually want to move towards supporting some sort of forms of distributed data frames. It comes down to how large the data you're processing is and how large the worker you have is. So, you know, right now, this is still early alpha stage. We're definitely in the getting feedback. You know, if PySpark is something that matters to you, by all means, please post an issue and thumbs up it. And like by seeing what people in the community want, that can help inform us in what we add to the product roadmap.
Yeah, really want to emphasize that we're doing this webinar, so you know you can tell us what you think is important. We have some good ideas, right? Obviously, Daniel knows his stuff, and as well as everyone else on the Astronomer team that have been working on this. But the best way to get the right answer is through making sure the community's needs are taken into account. Daniel, I think that as far as all the questions that would make sense to answer in the webinar, I think we're good here. So much good stuff, everyone. I think we'll have more around the types of decorators that'll be made and so on in the future here. But I think as far as this I can't talk today. I'm still in vacation mode. I think as far as this session goes, we finished a little early, and I think we can just call it. Absolutely great work, everyone, and really love the engagement here.
Barrage, is there a place that people can reach us? Because I do see a certain number of questions that I would love to answer, but of course, maybe not for the wider or just.
Yeah. We have these questions that we'll get them offline and answered in email. So all the questions are saved. So we will kind of follow up with them. And, you know, I'm going to drop my email in the chat as well, just to make sure if anybody else has any additional ones, please be sure to send them over and we will make sure that they get answered. Let me just check the chat once more. Cool. Daniel, anything else you want to say around this?
Oh, well, actually, there is a couple of things. Firstly, I noticed someone asked about the concept of schemas. That's a very important thing to bring up. We actually do have a concept of schemas where Astro is actually able to, you can create, we actually store all of our temporary tables in between tasks in a temp schema unless you explicitly state your schema. So no, Astro will not like litter your database with tables all over the place. We will put it into a temp schema so that it's easy to just delete all of your temporary tables in one swoop.
Oh, yeah, good call out there.
Yeah,
that's a big one.
To the question about the Kubernetes pod operator, this will still work with any other Airflow operator. So you can have like an Astro DAG and then still use like the normal Airflow dependency setting to set it with a declarative operator.
Awesome. Love that feedback, Mitro. I love the way our API is coming out as well.
You do have the option to specify your schema. So if you look on the documentation, we kind of clarify pets versus cattle. So if you say that put this in the schema, we put it in the schema you ask us to. Otherwise, we default it to a temp schema that is easy to delete. But yes, thank you guys, and thank you all so much.
Awesome. Thanks, everyone. Like the follow-ups will be in your inbox soon, and looking forward to hearing your feedback. Thanks so much for joining us. Talk to you all soon.
Bye.